Good day. You are welcome to another unit of Physics 191, and in this unit we are considering the simple pendulum. The simple pendulum. And at the end of this unit, you should be able to set up the simple pendulum experiment. Secondly, you should be able to record the period of oscillation of the simple pendulum, and also you should be able to plot a graph of t squared, the square of the period, against L, that's the length of the pendulum. And finally, you should be able to find an estimate of G, that's acceleration due to gravity, from the slope of your graph. Now, the simple pendulum. The idea of the simple pendulum actually consists of a point mass, you name it M, that is suspended from a rigid support, most likely a rotor stand, and by a weightless and inextensible string. And most times, this weightless and inextensible string we use thread for it. And the second thing you should note on simple pendulum is that if the amplitude of the motion is small, the angle is not more than a few degrees, then the motion is simple harmonic. Which means that if you are carrying out simple pendulum experiments, you should ensure that the angle of oscillation is not wide, is not large. You let the angle be small as possible. With this, you can get simple harmonic motion. We have the expression for representing the period of oscillation of a simple pendulum, which you are looking at, which is T equals to 2 pi square root of L over G. Now T, like I said, is the period of the oscillation. 2 is a constant, pi is also a constant. L in the roots is the length of the pendulum, which is the length of the thread, your weightless inextensible string I talked about the other time, and G is the acceleration due to gravity. Now from this equation, if you linearize this equation, you have T square equals to 4 pi square multiplied by L over G. Now, having your T square plotted on the vertical axis and your G on the your L on the horizontal axis rather, you can conveniently bring out the slope of the graph, and the slope of the graph will help you to determine acceleration due to gravity. This diagram is showing a setup of simple pendulum. You can see the thread, you can see the rigid support like your rotor stand, and then the bulb. That bulb is the mass that I talked about the other time. You see the ruler to measure the length of the pendulum. Then you see the stopwatch. The stopwatch is for you to time the oscillation of the bulb that is going through simple harmonic motion. And the last diagram you are looking at is actually a schematic diagram of the motion. At point B, as you can see, that's when the mass is at rest at equilibrium position. And at point A, it has reached the maximum position, the amplitude from the equilibrium position on this side. And on the other side too, at point C, it has reached the maximum position, that's the amplitude on the other side also. And you can see the angle, theta there, is even less than 10 degrees. And please take note of this. For emphasis sake, the angle should be as small as possible, the angle of oscillation, for you to have simple harmonic motion. And in summary, you have learned how to set up the simple pendulum experiment, how to record the period of oscillation of the simple pendulum from the expression I gave, T square equals to 4 pi square root multiplied by L over G. You have also learned how to plot a graph of T square against L. T square will be on the vertical axis and L will be on the horizontal axis. And finally, you have learned how to find an estimate of G from the slope. Once you plot your T square against L, you have all other components attached to your L as the slope, and from there you can bring out your G. Thank you.